Hello, good morning everyone. Our project is titled Removal of Suspended Solids from Wastewater with Pumice Media Filter. Um, Alan?
எஸ் கேட்குது
எஸ்
பேசலாம்.
கேக்குது பேசலாம்.
கொஞ்சம் வீடியோ மட்டும் ஆன்
வீடியோ
பண்ணிக்கங்க
Okay,
மட்டும் ஆன்
எல்லாரும்.
பண்ணிக்கங்க எல்லாரும்.
okay, sir. Nowadays, we are needed water, pure water for our daily purposes, but lots of wastewater in the society. So we decided to wastewater into normal water with some method. The method is a filtration method using a Pumice media. So the introduction of our project is waters become a rare resource in the world. Since most suspended particles can easily pass through the spaces between the grains of the filter media, staining is the least important process in this filtration. So filtration primarily depends upon a combination of complex physical and chemical mechanisms, and the most important being adsorption. So the next objectives of our project is first of all to study the quality parameter of wastewater and study the filter media of filtration bed, and to select the filter media with a varying depth, and also analysis the effluent from the media bed. First we collect the wastewater, and the wastewater sample collected in police quarters, third mile in Tuticorin, and then methodology and materials of this our project. Material selection, materials are about sand and pumice media, and the main ingredient is pumice media, and then the filtration bed using cotton charcoal, and then the drainage gravel also. First arrangement of filter bed in 60 centimeter, like each bed is also 50 mm. And then the wastewater sample collection, water quality analysis. For we collect the wastewater, and that wastewater is included into some water quality testers, and then water quality testers after the arrangement of filtration bed. The water is included in the filtration bed, and then influent filtration in filter media bed. Last we collect the effluent water, and that effluent water is also included some water quality analysis test, because of this water is using of that purposes. And then next, materials under study, samples that are collected from household environment only, and um, we also the Pumice media is purchasing in an online effluent from the filter bed also. And then water quality analysis, we are concluded some testers in wastewater like pH, dissolved oxygen, chemical oxygen demand, and biochemical oxygen demand, and turbidity, total suspended solids and total dissolved solids. And other water quality testers in the wastewater included in a chloride conductivity, hardness, sulfate, and color. pH is the negative logarithm of H plus activity in water. pH value is a measure of acidity and alkalinity of the solution. The lower value of pH is 4, produce sour taste, and higher value of about 8.5. And then the pH meter is calibrated with pH 4, pH 7, and pH 9 buffer solution. After the calibration, the electrode is dipped into the polluted pond water under study, and pH is noted for the test. Turbidity is one of the principal physical characteristics of water and wastewater. It is caused by the suspended matters or impurities that interface with the clarity of this water. Turbidity is measured using the turbidity meter. And the total suspended solids. The total suspended solids include both sediment and organic materials in a suspended in water and wastewater. And this formula is about TSS is equal to A minus B into 1000 divided by C. TSS is about total suspended solids, and A is the end weight of the filter paper with residues, B is the initial weight of the filter paper, and C is also the volume of the sample filtered. And then total dissolved solids. Dissolved solids, the total amount of charged ions, including minerals, salts, and metal dissolved in the given volume of water. It is expressed in a units of milligram per unit volume of water. And then TDS formula is about A minus B into 1000 divided by C at the same formula of total suspended solids. It's also the same characteristics, and the C is also the volume of water filters. And a chemical oxygen demand. Chemical oxygen demand is a measure of capacity of water and to consume oxygen during the decomposition of organic matter and oxidation of inorganic chemicals such as ammonia and nitrate. COD is a the dichromate reflex method is used for this, and the test was carried out as per the standard method. And biochemical oxygen demand, a measure of amount of dissolved oxygen consumed by anaerobic organisms while stabilizing decomposable organic matter under aerobic condition. And in decomposition, organic matter serves as a food for the organism and energy results from the oxidations. BOD measurements are used for the conductivity, and then electrical current results from the motion of electrical charged particles in the response to forces that act on them from the applied electrical field only. Conductivity electrode is dipped into the sample. Example, polluted pond water, and the conductivity is determined. And harness is most commonly expressed in milligrams, a calcium carbonate equivalent per liter. 20 ml of standard hot water is taken for the conical flax, and to this a 1 ml buffer solution. Buffer solution is about ammonia and water and the ammonium chloride. And 3 drops of EBT is added. EBT is known as the erythrom black tea. And now the content is the conical flax tanned into wine red color. This is the titrated with against EDTA, and the endpoint is appearance is a steel blue color. And then specific gravity. Specific gravity or relative density is a dimensionless quantity that is defined as the ratio density of the substance to the density of water at the specified temperature. And the specific gravity formula is known as a specific gravity is known as a substance pair preference. And the density, specific gravity supports density. Test of specific gravity, drainage gravel, test for drainage gravel, separation gravel, filtration sand, pumice stone, all these materials to having the specific gravity test for this project. And then is Nasir is explained these also.
Thank you, Ali. Good morning to everyone. Now we'll see about the compact ductility. In a right side image is a normal solid. It do not compact by the compacting rod, and the compacted solid is this no moisture and no air. But in normal soil, the air and moisture in the gap of the soil. So we compact the soil. Alan change.
Have you identified any industry for
The impact testing is done in drainage gravel and separation gravel. The properties of pumice stone. In this project we take about the pumice filter media in the pumice stone. The pumice is formation in the volcanic eruption. The volcano is dissolved in the ocean water. Then it is formed by the foam material. Then it is dried. In dried state, it is a translucent property of a very light material that is called the pumice stone. It is a very translucent properties. This is the we used the pumice stone. Next, the proper composition of the pumice stone is it is a chemical composition of the volcanic glacier state. It is a very thin and translucent bubble state. It existed in the volcanic rock. It is used for the beauty salons, and it is very helpful to the beauty tips for others. Beauty salon. It is the composition of the silica and high silica and low iron and magnesium.
Yes or no?
Next we choose the Pumice Media filter in charcoal material. The charcoal is the purest form of carbon. It is made upon the cooking wood. Cook, cooking wood in the low oxygen. The quality of the charcoal is defined as the various combustion character. It is a figure. It is with the high level of fixed carbon and low level of the ash and volcanic. Next. It is a pictorial representation of the charcoal when we used it. Next. The pumice formation okay. It's okay. Next, Alan, next. We use the two pumice filter media. One is a pumice media filter and another is a control media filter. The pumice media filter is arranged by the cotton for 50 mm and charcoal for 50 mm and fine aggregate in 150 micron size for 50 mm and separation gravel for 50 mm in 5 micron size and pumice stone for 50 mm and in a top layer 50 micron size of drainage gravel in the pumice media filter. And in another ways we use the control media filter. The same 50 mm of cotton and 50 mm of 50 mm of charcoal and 50 mm of drainage fine aggregate and drainage separation gravel and drainage gravel of 100 mm. We extending the pumice media in 50 mm into the drainage gravel for 100 mm. Next.
Thank you, Nasir. Now I will be explaining about this filter media. So, coming to the control media filter, for years of practice, we have been using only the control media filter. That is, if we refer the old journals, we have come to know that the before projects, many have done using this control media filter, which is nothing but in this media filter we are using the cotton as a base, so that the sand and other particles wouldn't come out. The next layer we are adding the charcoal, as we said in the earlier, that is before explaining about that material, we know that charcoal is a purest form of carbon, which is used as a filter media. So we are using the charcoal as a filter media, and the next part we are adding the after that we are adding sand. That is, we can say it as a fine aggregate. Also, then we are adding the separation gravel and also drainage gravel. For the control media filter, we are using the drainage gravel for 100 mm. Other parts we are using at 50 mm. Now this is a pictorial representation of our control media filter. From the bottom you can see that we have kept a cotton there, then we are using charcoal, then fine aggregate, that is sand, then separation gravel, then we are using that drainage gravel for 100 mm. Now coming to the pumice media filter, as we did in the control media filter, for years I have said that many many journals have been using that control media filter. In this pumice media filter, we guys have replaced that 100 mm of drainage gravel as 50 mm of pumice stone and 50 mm of drainage gravel. Now you can see that as in the same like that of control media filter, we have introduced cotton, then charcoal, also the drainage, the separation gravel, then we have introduced the pumice stone, also the drainage gravel at the top. Every materials we are taken in the quantity of 50 mm. Now this is a pictorial representation of pumice media filter. You can see the difference compared to that, so that you'll get an idea. So So after observing the effluent as well as um, after observing, we can see before uh, testing the water from the introducing it into the control media as well as Pumice media. We can note the changes. That is, you can see the tabulation, how much difference we get as in the percentage. Also, now you can see the influent as well as effluent. Influent, most probably we have get a better result compared to that control media filter. That is the reason we have chosen the Pumice media filter in this project. Conclusion of our project, the main objective of our project is to reduce the water scarcity. We are in every homes, we are using that utility water as a sink water or a bathroom bathing waste water, uh, simply to the ground. But we can we can recycle this water using this particular Pumice filter, so that the turbidity and other dissolved solids in the wastewater get filtered, and this can be used in the household, like bathroom flush, urinals, like that. We can use for this, so that the fresh water can be conserved. Um, as for a large quantity, for this 25 liters of space, we have spent nearly 2000 rupees, so that you can calculate the amount of media filter you needed to fit in your household, so that you can reduce the use of fresh water in your homes. Thank you.